know how you judge math things on whether they're cool or not. So it's hard for me to answer that.
The international coolness level.
Chamber roll can be frustrating at first until you get used to looking for it. But usually after about a week it's fine.
A week? I can't do a week. I don't have that kind of time. Okay, that's a good one. Kill me later. Try that. Try.
Does that mean we have a Unit 2 test? Is Unit 2, or just like Unit 2?
I don't. Say your question again. Do you have a second test in this class? Yes, eventually.
Well, I'm saying on the 27th.
Yes, that sounds correct.
Oh,
That's what
dang
it's
it.
been up that. That has been the approximate date for like a week and a half.
Oh. Well, it doesn't say Unit 2 test, so I kind of just think you're talking about like Unit 2. No?
Well, I guess you can call it a quiz if you'd rather. But it's
How
kind
many
of
points is it?
40 to 50.
It's a test.
Sir.
It said a few on 27.
We don't have time to do that now. You're gonna have to. You're gonna have to try to finish it on your own, but I'm not taking it up today. So.
I was working on the homework and there's like 2 or 3 that I still.
Okay. Well, you've at least narrowed down the choices then. But we're not looking at product rule, quotient rule anymore. Y'all have had lots of class time for those.
That's crazy.
How you doing, Mr. Townsend?
I'm good. How are you?
Pretty good. Did you sign me up this week?
I haven't yet,
You haven't yet?
but I might.
Two big questions. And I was like, what? She's like, what are they gonna be? And I was like, what? And she was like, you turned out to feel like the test last year. And I was like, I don't think I ever remember. I didn't go see the movie.
Okay, I've got 2 handouts for you guys to pick up, so please go and get those.
I thought it was some people think it's more I think I just
3.
no, it's like
Sam was late.
I'm not gonna get posted for AB Center in the cafeteria. Can I go run and get it really fast?
You can, but you're already late, so.
I'll take the 3.
Village choice. Earl was late. 1, 2, 3. 2. Olivia. Set her stuff's here. Yeah, she's late. Trent. Lincoln's All right. Before we get started here, I want to give one last chance for full credit on number 24. Number 24 was one I asked you to turn in the Google Classroom in class last time, and for homework if you didn't have time to turn it in class, and if for some reason you forgot or for some reason your Wi-Fi was not working, this is your last chance to still get full points. If I don't get it before we start our notes here, then it will be considered late. So, anybody need that to turn in? Number 24. It's under bell work. 24 is from a few classes ago, so there's no reason that one shouldn't be finished. Okay, then we are moving on to the last big topic in this Unit 2. So Unit 1 was all our limit stuff. Unit 2 is how to take derivatives and a couple of applications. But today we're getting into chain rule, and honestly this is probably the most important thing we do all first semester. So it's not that chain rule is a different type of derivative question. You're still going to be using power rule sometimes a product rule, sometimes quotient rule. But after you do those things, sometimes you have to do this chain rule process. So it's really adding one step to the end of all derivative problems. Now, what makes this kind of challenging for students the first week or so that you see these is you kind of have to retrain your brain that after you take a derivative, like you've been doing, you then have to consider chain rule. You don't always have to use it, but you always have to question yourself whether you're doing that. All right, so chain rule is when we want to take the derivative of a composite function. So that's when you have a function plugged into another function. So, just to illustrate why this is kind of needed, I tried to make up a real basic example here. If I just tried to do power rule on this, if I bring this 2 down, lower the power by 1, you might think that the answer is 2x cubed. But because of that inside, x cubed, it makes it where that's not actually true. So let's look at what the answer should be with exponent rules, and then we'll talk about how you could do this with chain rule. So you could rewrite this as this, using exponent rules. The power to a power is multiplication. And then you could bring the power down and lower the power by 1. So this works, that does not work. And it all has to do with that inside function. Alright, so how should we approach this if we're not trying to just use exponent rules? Well, you really need to think of this as like an outside part. We've got something being squared, so I'll just say u, something being squared. And then there's an inner part, which is like the x cubed. You got to identify the inner part and the outer part. Now, on this side of our notes, this is going to sound kind of wordy, and it's not as complicated as it sounds. Usually after you see a few examples, it'll start to make sense. But what the chain rule says is, first, take the derivative of the outer part. So if I take the derivative of the outer part, it would be bring the power down, lower the power by 1, but with the inner part plugged in. So instead of saying u, call it x cubed. Take the derivative of the outer part with the inner part plugged in. Then you need to take the derivative of the inner part, which would be 3x squared. And then finally, if we take the derivative of the outer part with the inner part plugged in, this guy, times the derivative of the inner function, which is this guy, we end up with 6x to the 5th, which you should be able to verify makes sense, because we did this with the exponent rules up here. With the exponent rules, we knew that this was supposed to be 6x to the 5th. It's a check mark. So, again, this is kind of wordy, but the derivative of the outside with the inside plugged in times the derivative of the inside is what we're going to be practicing. Okay, question 5 what I would call the outer part is I've got e to something, and the something that's being plugged in, the inner part is 4x. So you have to take the derivative of the outside part. So what's the derivative of e to something? Okay, e to something. The derivative of e to the x is e to the x. Okay, but then it says with the inner part plugged in. So don't say something, say what it was. We also have to compute the derivative of the inner part. If the inner part is 4x, that's the function that's being plugged into another function. 4x is being plugged into e to the x. It is 4. And chain rule says in order to take this derivative, you've got to take the derivative of the outer part with the inner part plugged in, what we did here, times the derivative of the inner part, which we did there. So we're really doing two things. We're using the same derivative rules, looking at big picture, but then we're coming back and we're multiplying by the derivative of the inner function, the thing that's being plugged in to the other function. Now, this is saying the same thing that I had just said, but if you want the derivative of a function with a different function plugged in, you need to take the derivative of the outer function with the inner function plugged in times the derivative of the inner function. That's what I had you do in multiple steps on the other side. But this is saying the same thing. I've got 2 Khan Academies assigned to you guys that we'll do after this other handout. And it's helpful to look at it this way as well. Okay, so here's the 2 examples we did. We identified the inner function, the outer function. We can take the derivative of the outer function with the inner function plugged in times the derivative of the inner function. Derivative of the outer function with the inner function plugged in times the derivative of the outer function. You got to multiply those together to get your derivative. Okay, so here's where it should start to click for you once you start seeing some directions or a few examples. Okay, when I look at this, I'm thinking power rule. I've got something to the 7th power. So power rule says bring the power down and then lower the power by 1. So what I just did is I took the derivative of the outside, the big picture, with the inside plugged in. I left it 3x minus 5x squared. And then the chain rule part says now come back and multiply by the derivative of the inner function, the thing that's being plugged into something else, the thing that's being plugged into x to the 7th. So that would be 3 minus 10x. All of that makes up the derivative. But this part is the chain rule part. Okay, if we rewrite this guy like this, so to me that looks like power rule. It's a little more complicated because it's not just x to the 2/3. But chain rule says you need to take the derivative of the big outside part. So bring down the 2/3, lower the power by 1, and when you take the derivative of the outside, plug in the inside into it. So x squared minus 1 stays x squared minus 1. Times the part that's new, the chain rule. The derivative of the inside would be 2x. So you have to multiply that to get your answer. This is the chain rule part.
So is that how you read that answer?
I mean, on the test, they would probably make the numerator 4x.
Okay.
So we're not worried about simplifying it all right now. A lot of times you can't do much either, especially if it's written like this. It's pretty messy. So the big hurdle that you guys have to get over as soon as possible is remember to take the derivative of the inside. Every question we've looked at up to this point was rigged to not have this issue. We would do like The derivative of sine becomes what? Cosine. Now, technically, you need to consider the derivative of the inside, but every question you've seen up until this point had a derivative. The derivative of the inside was 1, and multiplying by 1 doesn't change anything. So we didn't need the chain rule before today. But when it's something like sine of 2x, again, you've got to take the derivative of the big thing like you've been doing. The derivative of sine something is cosine something. That's the derivative of the outside part with the inside part plugged in. That's how I worded it on the front page of our notes. And then you need to come back and multiply by what? 2. The derivative of the inside, that part is what is considered chain rule. And that should kind of make sense on this question. I know some of these functions are weird enough that they're hard to see. But if the derivative of sine is cosine, if you put a 2 here, that's making the x value grow twice as fast, which means that the slope is growing twice as fast. And so it can't just be this. It's got to also have that. Okay, one more. What's the derivative of tangent something? Okay, secant squared of the something. That's the big picture thing. Bless you. That's the derivative of the outside with the inside plugged in. And then chain rule says you need to come back and multiply by the derivative of the inside, which sometimes that's not anything you have to do, but you always have to consider it. And the derivative of our inside would be what? 2x. So all of that makes up the derivative. So this one last little layer is what we call the chain rule. Okay, so we need to practice a couple of these on pencil paper. So I'm asking that you get through at least 10 of these, partly because there's a couple of these you won't know how to do. You don't know how to take the derivative of inverse tangent on number 10. I haven't shown you what that is yet. It's not a real important one, that's why we can save it. But just for a little bit of guided practice here before I ask you to try a few more, try question 1 before you try any of the others. Okay, so looking big picture here, you should have thought of this as one big power rule to start off. You should have said, bring the power down, lower the power by 1. That first part is no more complicated than anything else we've done. It just looks messier. Still just a power rule. But to be correct, you needed to then go back and multiply by the derivative of the inside. So you need times a 12x plus 7. And you don't need to worry about simplifying at all. But all of that should be part of your derivative. I'll try to do all of the chain rule in purple for consistency. Again, don't spend any time simplifying on these right now. But is everybody okay with this red part, where it came from? Everybody okay with where the purple part came from? Okay, I'm going to suggest you try 2 and 3 next. Again, don't worry about any simplifying, just quick and easy. Power rule, consider chain rule. Okay, I'm cutting you off there because again, with no simplifying, it should be fairly quick. So, number 2, looking at the big picture here, I've got something to the -2. So the power rule could be bring the power down, lower the power by 1, but all of that inside stuff stays the same. This is the derivative of the outside function with the inside function plugged in. Leave the inside stuff alone. And then the chain rule part is you had to come back and multiply by the derivative of the inside, which would be 8t minus 3. And don't worry about simplifying. Okay, number 3. If I do power rule, I could bring the power down, lower the power by 1. I don't know. Or you can leave it up there if you made it -2/3. That's fine. But the chain rule says I need to come back and multiply by what? Right, the derivative of the inside, which is -8. The purple part is the new layer that I'm asking you to consider. Okay, everybody okay with 3? Okay, I'm giving you less time on the next ones. Try 4, 5, and 6.
Oh, just cosine is 90%. So yeah, so if I just do positive signs.
Okay, so you may not have memorized this one yet, but you do need to do that before we get to our next test. So the derivative of cosecant something is negative cosecant cotangent, I believe.
Yes.
Okay. Okay, now, the thing that you guys need to be worried about, and I know this seems obvious because we've talked about it on every question today, but on the test, if this question was on there, I'd say this is a good likelihood that this is one of the answers, but it's not the right answer. You have to make yourself every single time you do derivative, unless you're just using a calculator, you have to remember to take the derivative of the inside. It's got to be 7 times bigger. Okay, the inside in this one looks like all of this. So for 5, you should have said the derivative of sine something is cosine something. The something just happens to be this big mess. It doesn't matter here. And then chain rule says you got to come back and multiply by the derivative of the inside. So you should have multiplied by 3 plus the derivative of tangent is what? Just secant, not cosecant. All of that. And again, multiple choice questions usually don't have the chain rule part there as one of the distractor answers. You have to train yourself every single time. All right, 6, the derivative of this, the derivative of tangent something is secant squared something. So this is where I'm taking the derivative of the outer part with the inner part plugged in, the inner part being 4 plus 10u. And then we peel that layer away, and it leaves behind the derivative of the inside part, which would just be 10. Still okay? Okay, you at least see where those are coming from? Okay, I would maybe skip number 9, just because we don't use that type of derivative often, but you're welcome to try it out if you want to. And you can't do 10, because I haven't told you how the derivative of inverse trig functions yet. In fact, I probably won't even tell you those until next semester before the AP exam, because those don't come up much. So it's kind of silly to memorize them right now. So next up, go ahead and try 7, 8, and 11. Try those 3. Okay, I'm stopping you already, because again, if you're putting too much more thought into it, then you might be looking at the wrong stuff. Okay, Christian, what's the derivative of 5? Okay, what's the derivative of e to something?
E to something.
Okay, just like e to the x is e to the x. The only difference is because we don't forget chain rule, we needed to come back and multiply by the derivative of the inside part. So the thing that's being plugged into e to the x had a derivative of
4 plus 7t to the 6.
okay. So as long as you remember that second, it's not that the second half's hard, but you guys will be surprised and you'll be very upset if you forget it on the test, because several of the test questions will be chain rule. Okay, so we just said the derivative of e to something is e to something. So g is going to be e to something. But because we never forget chain rule, we can come back and multiply by the derivative of the inside, which would be 0 minus negative sign, so times sine x. This number 11 seems to be one that you guys haven't, or a lot of people haven't memorized yet, but what's the derivative of natural log of something? Okay, well if it's natural log of x, it's 1 over x. If it's natural log of some other stuff, it's 1 over all of that stuff. Times, if the derivative of the inside is not 1, we have to come back and multiply by the derivative of the inside. So negative 10y plus 3y squared. It adds an extra step, but it shouldn't be any harder than other power rule stuff. Okay, so we've skipped 2 so far. So you need, what, 3 more? Is that right? To get to 10? Okay, take your pick. Pick out 2 or 3 of those. And I'll go over all 4. But it's really just trying to frame it in your head and get that last part to stick. Now, not that you guys really care right now, but after our second test, our third test is over related rates and implicit differentiation, and both of those are really just chain rule, like a different application of chain rule. Well, the inside here is e to the 6th. This is like sine of e to the 6th.
So would you just do chain rule twice and
You have to do chain rule on this one. And then over here, you only need power rule. Bring the 6 down, lower the power by 1. Then his inside is z, and the derivative of z is just like the derivative of x.
Chain rule plus chain.
You do power rule that needs chain rule, and then power rule that doesn't need chain rule. I'm going to go over all of them.
Where's my brain? We're thinking.
On this one, it might be helpful if y'all write it this way. Sine to the 6th of z is the same thing as the sine of z to the 6th. You can still use power rule on that.
because the power rule. Okay. Mr. Hilton, could you work number 13 so we could see?
Yeah, I'm gonna go over all 4 of them.
Oh, okay.
Okay, for question 12, the derivative of natural log of something is 1 over the something. But then because of chain rule, you had to go back and multiply by the derivative of the inside. So derivative of the inside would be cosine x. And then the derivative of cotangent is negative cosecant cotangent. Is that correct? That's not correct. It's negative
But since it's a negative times a negative.
cosecant squared. That's right.
Yeah.
Oh, so yeah, negative of a negative should be plus. I knew that one. You guys okay with where this is coming from? Again, I'd see why maybe you don't have that part memorized yet. You can see I know that one. I don't know why I said that, but okay, 13. So when we take the derivative of sine something, we get cosine something. But if the derivative of the inside is not 1, we have to multiply by the derivative of the inside. So times 6z to the 5th. Then over here, again, these two are the same thing. With trig functions, we just like to put the exponent here, but it means this. So this one does not need chain rule. You just bring the power down. Okay, I'm lying. It does need chain rule. I'm wrong. Bring the power down, lower the power by 1, and then what was the inside function? Okay, and what's the derivative of the inside function? Cosine. So you need all of that. This is like something to the 6th power. So I brought the power down, lowered the power by 1, and then considered the derivative of the inside. Okay, if 14 was one that you did, you should have done the power rule, bring the power down, lower the power by, bring the power down, lower the power by 1, but then also multiplied by 7, the derivative of the inside. And then over here, the derivative of e to something is e to something, but the inside part there was negative w, so just like negative x, derivative, same thing. The derivative of the inside would be a negative 1. So that changes it from a plus to a minus. Okay, and then if you did 15, bring the power down, lower the power by 1. In this example, z is the inside thing. The derivative of z is 1, so I don't need chain rule. You can write times 1 if you really want to, but there's not really an inside part there. But over here, the derivative of sine something would be cosine something. And the derivative of the inside part there is certainly not 1, so we need to multiply by his derivative. So you need a times 2z. Again, it's not a new type of derivative. It's still power rule, maybe product rule, maybe quotient rule. Still memorizing derivative of sine, derivative of cosine, derivative of cotangent. But you have to train your brain to consider, after you do it, times the derivative of the inner function, times the derivative of the inner function, times the derivative of the inner function, times the derivative of the inner function. Every single time you forget that, there's a good chance you're going to miss the question. Yes, Grace?
Why would 14 be 1 over 2 times the square root of 7w and not just w?
Well, the derivative of this is that. So 7w does the exact same thing, but then because of the chain rule, you need to come back and multiply by 7. It's still the same thing. Square root of something, you bring the power down, lower the power by 1. If there was an x under there, it stays x. If it was a 7w, it stays 7w. Yes.
Do you find the second part of work for you with e to the
Okay, so I had this. This was a plus sign, so I had a plus sign here. The derivative of e to the x is e to the x, so the derivative of e to something is e to the something. But what's the derivative of the inner function? What's the derivative of negative w? So instead of saying times negative 1, I just made this a minus sign. Yes, Elise.
15.
Yes.
Why on 3z to the 7th, so z's the only inner part? How do you know that?
Because it's the only thing being raised to the 7th power.
So
The 3 is not being raised to the 7th power.
Okay, so you don't include the 7th power on the inner part, just the z.
Right.
Okay.
So I've got 3 times something to the 7th power. So
Okay.
bring the power down, lower the power by 1. If it's an x, you leave it an x. If it's a z, you leave it a z. If it's a 7w, you leave it a 7w. And then you have to remember to come back and multiply by the derivative. Well, since this had a derivative of 1, I didn't really write the chain rule. Multiplying by 1 doesn't change anything.
Okay.
It's just to be clear too, all the derivatives you've been doing were still correct. All of the questions you've seen thus far were rigged where they did not need chain rule. So they always had a derivative of an inside of 1. So that's why we didn't need that. Okay, I think you should leave your notes out, and I think you should leave this example out. But I would like you to practice this on the 2 Khan Academy assignments. I think one of them has tables, and you might want to use your notes where it's written this way. But it's, again, it's just a mathematical notation. It's a mathematical way to describe the same thing I've been saying. The derivative of the big outside piece with the inside piece left alone times the derivative of the inside. Coming back and doing this part is what we refer to as chain rule. Now, I don't know how accurate this was, but like 3 or 4 years ago, I did do an AP training, and the guy who was leading it, one of the probably the top 5 calculus people in the nation. And between questions like these and when we do implicit differentiation, which is really just chain rule looking a little different, and related rates, which also considers chain rule, he said that he approximates about 25% of the points you can earn on the AP exam come from the chain rule property. So gives you a good idea of how important this one's going to be. So I know you guys can do it, but the sooner you train yourself to always, always, always check for the chain rule, the smoother it'll go. Okay, I will come around and help in just a bit, but right now I'm sure you don't know what you need help with yet, so I'll get a couple more of these homework papers turned in.
catching up to some. Yeah, but I was camping, I was like in the middle of nowhere.
Gotcha, it's still worse than the middle of nowhere. Which ones were you struggling with? So, this is H. What you need to do is do the product here first. If I take the derivative of something times something, it's like looking at the derivative of the first, the second one alone, plus the derivative of the second. The first one alone. And then if you want to go to 5, it's going to be the derivative of f of 5 times g of 5 plus the derivative of g of 5 plus the derivative of 5. I mean, that's why they give you those. You need to write out the subject. That should be the same for the other one too. Are you stuck on this one? You might need to think of it like that. Because then it tells you the parts and like how it fits together. Again, the one with tables, I froze the screen, the part of your notes you probably want to look at. outside function with the inside function plugged in, so what is takes a random one? 4. Okay, so that's supposed to go into the derivative of the outside function. So what's the derivative of d at 4? Okay.
These are so bad.
Times the derivative of d at -1. Why don't you take you should write it down. If you write that down, now first thing I would do is change the f of u to
It's hard to.
then one number comes from the table, second number comes from the table, third number comes from the table, and then we'll know how to throw them all together. I can help with you.
To simplify this down.
Well, enough to figure out what the answer is going to be.
Wait, so I just do.
Alright, we'll start over. See if I can get here.
plugged into the outer derivative. But I'm saying that's, I agree with you that that's -2, but then that gets plugged into the derivative of the other function. Okay. So derivative of f at -2, 28, and then that gets times by the derivative h prime. And that's 4 years. Those are hard for me. Honestly, the easiest way to do those is to write that down and then to start like scratching that off with the number when I find it, scratching that off when I get a number, find it, scratch that off when I get a number and find it. But the more of that you kind of do in your head, it's much harder. What are you doing instead? I don't follow you, but if you've got it, I don't really follow you either.
Is it that? Yeah. What was that? Oh, good. Very good.
Write that formula on your paper.
Yeah.
Okay, let's do it with F and B's. What's wrong with that? F and B's? This will be F prime G of X. It's the derivative of the outside, but you didn't put part A. Times the derivative of X. Okay, so you want to know F prime of 3. So you're going to plug 100 in here. What's G of 3?
Which one?
Zero.
Okay, so put a 0 there. Okay, what is it? F prime of 0. And then you're going to multiply that by. Okay, you're good.
Oh, it's all, it's all.
Why is it?
Anything deeper on the
I did 3.
Okay, well, you're not looking at this, so I don't know if you're just guessing it. You need the derivative of G.
I think it's red.
Yes. Okay.
Wait,
so
then-
Two times that. But forcing yourself to write that down, yeah, change some of the numbers, change some of the numbers, and then it's a lot easier to find.
7. How did I get 7?
Thanks, sir.
So. Why is it coming? Dang it.
Okay, so start over.
It's not 2 times -3, but F prime is not 1. F prime is 3, not 2. You're saying 2 times -3, and I'm saying this doesn't say 2 times -3, it says F prime of 2 times Write that on your paper. Here. Now write this on your paper. Like that whole thing down. So maybe instead of doing G of X, do H. Then you're doing my work.
I finished my work. Actually, no, I haven't missed one. I have something to do that big part. Go for it then. Well, technical too, but I missed.
So you need to know what H4 is. That gets plugged into the derivative of the other function. So like the derivative of f of negative t. Times, so 28 times, the derivative of the inner function, which would be the derivative of h. Okay, so 28 times 1. Well, you are multiplying at the end, but that part on the left, that's the inside part, it's a derivative of the outside function with the inside function plugged in. So you need to figure out what the inside function is to get a number. Plug that number into the derivative of the outside function to get a number. Multiply that number by the derivative of the outside function. Yep. I can do that. It's a logarithm property. If you have a number and its exponent is log and the base is the same number of something, it comes out to be something. So they've got e to the natural log of something. E to the log base of e of x equals up to x. That's the log property that we memorize. Okay, I haven't been able to check to see which ones you guys have finished and whatnot, but if you're catching on quickly and you're finished or close to finished, I am asking for one more assignment in Google Classroom between now and Wednesday, so you should do that before you call it quits for today. But we got plenty of time baked in here to make sure that you guys get a good grip on what you're supposed to be doing from these Khan Academies. Chain rule is way too important to feel shaky on. I would say that the table questions are a little less important. But. and then we do classroom.
Trying to kind of find a little bit, when I look at this, it's kind of like the derivative of e to something, it's just going to be e to that something. It's just like e to the x cubed. So that's why this and this is the same. And then because of chain rule, if the derivative of the inside part is not 1, the derivative of x would be 1, but the derivative of natural log of a times natural log of a is just 1. So the derivative of that would be times natural log of a. So that's this part's the chain rule. Just like if this was a 3x, like if this was the derivative of e to the 3x, we would have e to the 3x, and then times 3 because of the chain rule. Natural log of a is just a chain rule.
You got the circuit pen, the speed in the forecast.
Well, that doesn't have any chain rule on it. This one is a chain rule question because you've got a function plugged into a function. Well, did you notice? Let's see if it's good. Let's do that. Okay, so this is an easier way to think of these questions. So if you want the derivative of f of g, you're going to have this. So write that on your paper, just like that. your question, it's not type of key, it's type of page, so maybe everywhere there's a key, the type of page. Over here, these aren't really keys, this is if you're really good, so when you say equal, it's these are this. And if you ever do that, say you're taking care of it. Or you can put an arrow. Okay, so the information you need is you need to know, if you want to know the derivative at 2, you need to know what h of 2 is.
The negative
Okay, so right below this, this one, -1. And that's going to get plugged into the derivative of f. Carry that down to. Okay, now what's the derivative of f at -1? Okay, so that part goes to -3. But bring that derivative to the outside part is going to be the derivative of h at 2. So what would that be? The derivative of h at x equals 2. The derivative of h is actually 1 equals 2.
So it's 26.
Okay.
But why? Like why would we have 2?
Because that's where you want the derivative at. Because see, this is, we could have right here substituted the x equals 2. Now when you do this, you have to so,
Let's just try it.
This. So I say write this out, but maybe instead of saying g of x, say h of x. Specifically, we care about the derivative at x equals 0. So maybe instead of all these x, you can take zeros. That was probably my last question. So what is h of 0? Okay, so that's a 2. That gets plugged in the derivative. So this is 2, but 2. So that gets plugged into f prime. So what is f prime of 2? So all that stuff on the left goes to 3. And then times, still need h prime at 0, which is -2. So this is the inner function plugged into the outer function out of the derivative of the inner function. Here's what this is 2, right? all of this was due from the table. 2 is what gets plugged in. It's not that you multiply by 2. So this, I think this 2 became this 2, but it shouldn't be here. This, f prime of 2 should be different. Okay, let's try it. Write out what you do. And then I'll try to see if but also we didn't get it right, so I would write it out. Outside of the one, the inside. We want the derivative at 4. Okay, makes it a little easier to see. So we have to figure out what h of 4 is and get a number out of it. Okay, so instead of h of 4, you're going to put 1.
No, H of 4. So we just need to.
You didn't use this at all. You're not using this. You want to know.
Like I'm not supposed
You're mixing your stuff up. I'm with you here. You need to erase this. You're doing part of it with one term and not with another. Okay, what is h of 4? Those are the big steps. So you've got f prime of -2 times g prime of 4. Write all that out.
to.
Now, what is f prime of -2?
Well, I started cycle into
Okay, so all of this becomes 28.
18 or something. And I just said,
H prime of 4.
that might be the writing notes
Okay.
about this part.
Tells it in 13.
Huh?
April.
Yeah, I'll fold the worst thing I've ever done. So, I can't, It's like, that.
I'm gonna try to really read it
Do one more.
How far are you?
I guess what so derivative of the outside and the inside plugged in.
I can't read
So
it. I
f
can't
G
focus. I
prime.
can't understand it. 'Cause I'm not-
F prime of G
Yeah, just it's like not even hard to look when I get into this.
Exactly.
It's just because I
So if you want the
don't.
derivative
About
of 1,
books.
I know.
I
then
can't
you figure out what
write
G prime of 1 is.
I'm like,
change that
I
to a
really
number.
took it.
Exactly. Like, the sentence makes it make so much more sense.
Really?
Yes. Exactly.
Help answer the questions too.
Yes. I'm doing that. And if there's a question that I don't know,
Times G prime.
what can you do?
Yeah.
You're trying to do that at x equals 1.
So is it just
-2 is G at 1. You don't need that number any other time.
probably?
I still think that you're skipping 3 steps. You need to write it out every single time. And just make substitutions. Derivative of the outside with the inside plugged in times the derivative of the inside.
Yeah.
If you want to know the derivative
If you
at
can say
1,
Not very much. Not very many important things. But I started at the end of
this
the
is in the table.
Even when I was reading the book, I would read
What
this
is G of
one,
1?
the analysis and read it and like write down notes about it because it didn't make
Okay.
sense.
Okay, this is in the table. What is f prime of, you see how I'm just plugging this in here? What is f prime of -1? And that can't be right then. What is f prime at 0?
Wait, hold on. But it says that if that's like regular G, it's gonna be prime.
Right. But right here, I want regular G. Over here, I want G prime. The first part of the chain rule is the derivative of the outside with the inside plugged in. So no derivative of this one. So what is the derivative of f at 0? Okay, and then this derivative of G at 1.
Or well, f prime is negative 3%.
Okay, and I would say the answer sheet. But I think until you force yourself to write out the whole thing, look up this in the table to get a number, then look up this in the table to get a number, and finally, at some point you have to plug this into the table to get a number. If you're not writing those steps out and you're trying to just do them in your head, it's kind of hard to do it first. So.
right here, I have these two square roots for the denominator, and then would this right there be? I don't know if I like wrote this part weird to make it.
I think this step looks okay.
That would be 2x to the 1.5 if I were to add them together.
Okay, so x to the 3 over 2.
X to the 3 over 2.
It's the same as 1.5.
Yeah.
And then
Or
6
2x to the 3 over 2, right?
2x to the 3/2.
Yes. And plus 6x to 1/2.
Okay.
I'm having trouble like figuring out how to combine these two together.
Well, let's see if we can try to pick out what the answer's going to be. Have you used this one yet?
No, that's the only one I haven't used.
Okay, so these currently have a denominator of 1.
Mm-hmm.
So you can multiply the top and the bottom by 2 square root of x
Yeah.
over 2 square root of x, 2 square root of x over 2 square root of x. And then if all of these have 2 square root of x as the denominator, you can push those together as one big fraction.
Okay.
But, and I think you're on the right track, so I don't know if I'd erase that. But when you did right here, you did x plus 3 squared, and you called it x squared plus 6x plus 9. And then you did product rule. Honestly, I think if you would have just distributed this would have been 2.5. This would have been 6 to the 3 halves and 9 to the x to the 1 half. Then you could have done power rule 3 times, and that would have been a lot cleaner.
Yeah.
Might have been a little easier to get to the final answer.
I see. Thank you.
Because you had to do that in the simplifying anyway, so.
Yeah.
All right, guys, we got about 5 minutes. So if you needed more chances to get your Khan Academies up to 100, then you need to add that to your to-do list for homework. And there is one assignment I'm asking you to turn in the Google Classroom. So please make sure you have that completed and turned in before I see you on Wednesday.